Okay, hi everyone. First video with our brand new intro music, which was designed by Mr. Jeremy Berg. He's done a terrific job. So today we're going to be looking at regression analysis, in particular what to do on your CAS. I might split this video into two halves. We'll see how we go for time because I'm a bit conscious of how long these videos go. But basically in a regression analysis, you're going to follow the steps there that are on your screen now. So you do a scatter plot, correlation coefficient, regression line, interpreting the slopes, coefficient of determination, interpolation, extrapolation, a residual plot, and then a report. So I've come up with this data set here, which is temperature versus number of accidents that happen, traffic accidents. And what we're going to do is we're going to go through this and we're going to work things out one at a time. So the first thing we need to do is construct a scatter plot. So if you want to do that, you go to Doc, Insert, Data and Statistics. And now if we think about it, do we think temperature causes accidents or accidents cause the arriving temperature? I'm hoping that you said that the temperature causes the response in accidents. So you should get a scatter plot that looks like this. Okay, that's our scatter plot. Looking at it initially, we can't see any super obvious pattern. It is somewhat linear, going, and I would say it's moderate. Hard to say without enough data, but that's our scatter plot. Next we need to do is we need to find the correlation coefficient and determine the strength of this relationship. So to do that, you're going to go back to this previous tab. To do that, you can go Control Left. And to find correlation coefficient, we're actually going to go two birds with one stone here. We go in Menu, Stats, Stat Calculations, Linear Regression. Put in your X, which is temperature causes accidents. And I'm just going to move this over to column D. You'll see why eventually. It probably doesn't matter too much, but I'm just going to put that there. Okay, and this gives us our regression line, our coefficient of determination, and our correlation coefficient. Okay, so 0.66. So our PowerPoint asks us to calculate the correlation coefficient and indicate the strength of the relationship, which is why I have this here. And we have 0.66, which is a moderate positive linear association. Okay, so 0.66 fits into the second category down. Next, we have determined the equation of the regression line. We already have that information in our CAS here. So for our line, it would be y equals mx plus b, where the m is 0.26 and the b is negative 0.47, right? So to put that in a regression line, you would say, in place of y, you would say the number of accidents is equal to 0.26 times the temperature minus 0.47. Okay, so that would be our regression line. The next thing it asked us to do was to interpret that regression line in terms of slope and y-intercept. Okay, we can do that. Well, this is a slope here, the m, the 0.26. So what this would mean is that for every increase in the unit x, so x is temperature, so for every increase in 1 degree of temperature, you can expect the amount of accidents to rise by 0.26, which is sort of a bit complicated. It doesn't really work out nicely that way. If you wanted to get a nice round number from it, you could say something like for every increase in 4 degrees of temperature, the number of accidents goes up by 1, because if you were to do that, if you were to multiply that 0.26 by 4, you would get over 1. But either of those is fine. Next you have the y-intercept, which you can interpret, which would be if the temperature was 0, the number of accidents would be negative 0.47, right? Or essentially 0, which isn't exactly accurate, but that's what the slope and y-intercept are telling us. Next. says use the coefficient of determination to indicate the predictive power of the association. Okay, the predictive power, so this is my correlation coefficient, this is my coefficient of determination. To say the predictive power, I turn this into a percentage. So 0.441 or 442 becomes 44%. So you would use something like this sentence. You would say 44% of the change in the number of accidents can be explained by the change in temperature. And it's important to use that specific terminology there, or you can say variance instead of change, but it's important to use that sentence starter itself, so then it's mathematically accurate. So I'll say it again. So 44% of the variance or change in number of accidents can be explained by variance or change in the temperature. Okay. The next thing it's going to ask us to do is interpolation and residuals, but I might leave it here to prevent the video from going too long. So thank you for your patience, and take it easy.